Everyone, good morning. Shall we begin the session? Today is a revision of the procedure-oriented language, that is the C language that is available. So first is the C preprocessor, that is how the C preprocessor is used, how the macro expansions are used, and what is the difference between the macros that is used with the argument that is used with the function. So what are the various features of the C preprocessor, how to use the arguments, how to use the macros that is available under the C preprocessor. So let's start with the C preprocessor. This is exactly as what the name implies. It is a program that process our source program before it is passed to the compiler. So whatever the data, whatever the scenario that is available, so we are passing the scenarios, we are passing the data to the next scenario, to the next data, to the next match. That means preprocessor command, that is also known as a directives from a form, what can almost be considered as a language with a C language, and we can certainly write the C program without knowing anything. Without knowing anything means there is no preprocessor directive that is used with the macro. So we can certainly write the C program without knowing anything about the preprocessor or the facilities. But preprocessor is such a great convenience that virtually all the C programmer rely on this. And this chapter explore what are the various terms, that is explore on this one, that is explore on the criteria that is available under the C criteria. Next is what are the various features of C preprocessor, or what are the various characteristics of the C preprocessor, why we are using this one. There are multiple steps that is involved from the use or from the stage of the C preprocessor, that is writing a C program that is used with the C preprocessor, to the stage of getting it executed. Whatever the stage, whatever the scenario that is used for the execution of the C preprocessor, that is used for getting the data that is used in the C preprocessor for involving it. And what we observe from the figure, that when we use the C preprocessor that is involved, that is available with the executed whatever the input, whatever the output that is available. Now, if we are writing a C program that is pr1.c, then the expanded source program that's stored in the file pr1.i. Now, when the object is code, when the object is stored, that is known as a pr1.obj. When we get executed, when we execute the code, when we get the, we can say the compiled code or the source code or exe file or the executable file, that is known as the pr1.exe. So one is obj, one is the .exe. And this also provides various feature known as the preprocessor directives, and each of these directives begins with the hash symbol. That means we are using the hash symbol for the preprocessor directives, that is hash, and then we use the directives. And we learn about the following preprocessor directives over here. That means in this book, in this chapter, there are two parts of the C preprocessors. One is a macro expansion, one is a file inclusion. So macro expansion is this one, then next one is a file inclusion. Now this is one of the example of the C preprocessors. First one is handwritten programs, then text editor, then C source program, that is the pr1.c, then preprocessor, that is expanded C program. That means first we write the C program, that is a handwritten program that is done by using the text editor, that is generating the code, or that generates the code as a pr1.c. Then using the preprocessor, we are expanding, or we are doing, or we are using next preprocessor or the expanded source code program, that is known as the object source code, that is pr1.obj. Next one is pr1.obj. Then next is executable code, that is pr1.exe. So that is used with the pr1.exe, that is available, or that is used with the data, that is used with the scenarios available with this one. So one is a handwritten program, then C source code, then C preprocessor, that is pri.i, then object code, that is pr1.obj, the linker, that is known as the, or that is known as the executable code, that is a pr1.exe. So these are the various preprocessor directive that is available within the C program. So one is a handwritten program by using the text editor, that is a pr1.c, then expanded, that is a pr1.i. that is used with the C preprocessor, that is used with the pi.c. That is an extended program. So the first is a C source code, that is pr1.c. Then there is a preprocessor expanded source code, that is a pr1.i, that is expanded code. Then pr1.obj, that is used with the compiler. Then linker, that links the data with the executable file. That means we link the data with the executable file, that is a pr1.exe. Then there is a processor editor, then input output. So there is a processor that is used, then input and output. So there's a processor, that is editor, program type from the keyboard. So the input that is given, program type from the keyboard. Then output, C source code containing programs and the preprocessor command. So whatever the program codes, whatever the source code that contains the program and the preprocessor commands. Then next processor is the preprocessor. Input is C source code file, then output is source code file with the preprocessing command properly sorted out. Then compiler, this is the source code file with preprocessing command sorted out. This is a compiler that compiles the data, that compiles the program into the next part. Then relocatable object code. Relocatable object code means we are objecting the codes, we are using the code that is a relocatable object code. Then linker, this is a relocatable object code and the standard C library functions. Then next one is executable code in the machine language. So this is executable code that is used with the machine language. So one processor is editor, next processor is preprocessor, one is a compiler, one is a linker. Now there are two scenarios in this one. We have done with A and B, that is the macro expansion and the file inclusion. What are the various files that is included in this one? Then C part over here is conditional compilation. Conditional compilation means on the basis of condition we are compiling the material, on the basis of the certain conditions, certain scenarios we are compiling the condition. Then miscellaneous directives. There is a miscellaneous directive that is also used with the miscellaneous terms. So let us understand these features of preprocessor one by one. One is a macro expansion. So this is have a look at the following program. This is define upper 25 main int I for I equals to 1, I is less than equals to upper I plus plus. So this is printf I. So this is a printf that is used with the I. So what is a macro expansion that I'm talking about? That is a hash define upper 25. This is the main int I for I equals to 1, I is less than equals to upper printf percentage di. So this is used with the I. And in this program, instead of writing 25 in the for loop as we're writing in the uppercase, we already been defined before main function through the statement. This is the hash define upper 25. And this statement that is used with a macro definition, or most commonly that's like a macro. And now what purpose that is support or is serve? During the preprocessing, the preprocessor replaces every occurrence of the upper in the program with the 25. And here is another example of the macro definition, that is the hash define pi 3.1415. That is used with the 3.1415 in the main subject. In the main program, this is available with the we can say the initialization of the variable and also the providing the value, that is the float r equals to 6.25 float area. So this is used as a two variable that is available, r equals to 6.25, one is a float area. Then area equals to pi into r, that is pi is 3.1415 into 6.25 into 6.25. At last we are going to print the area, that is printf. This is the area. So this is the main function, then float r equals 6.25 area. This is area equals to pi into r, then printf. This is the area of the circle, that is the area. And this pi in the above program are often known as a macro templates, whereas 25 and 3.1455 also corresponding macro expansion. And when we compile the program, before the source code passes to the compiler, it is examined by the C preprocessor for any macro definitions. And we use the hash defined directives, that is goes through the entire program in search of the macro templates. And wherever it finds one, it replaces the macro templates with the appropriate macro expansion. And only after this procedure that had been completed in the program, handed over to the compiler. And in case of the C compilation, C program it is customary to use capital letters for the macro templates. That makes it easy for the programmers to pick out all the macro templates when reading out through the program and reading the data. And note that the macro templates and its macro extensions are separated by the blanks or the tabs. A space between hash and define is very optional. And when we talk about the macro definition, that is also defined, that is never to be terminated with the semicolon. This not be terminated with the semicolon. Now, how we use with the hash define, so that is used in the above program, that is we gain in by substituting the PI for 3.14 in the program. This is the define hash define clear screen. This is this one. This is clear screen appear in the program. It will automatically replaced by the program. And that is defined PI in a hash directive. You only need to make one change. That is the hash define directive itself. That is the hash define PI 3.141592. Beyond this, the change should be made automatically to all the occurrences of the PI before the beginning of the compilation, that is used with the hash defined directives. So in case of the PI, we are also using the PI templates. We are also using the macro template, that is the capital PI. It is insufficient since the compiler can generate the faster and the more compact code for the constant than it can for the variable. Secondly, when we use the variable for what is really a constant, encourages the sloppy thinking and makes the program more difficult to understand. If something never changes, it is hard to imagine it as a variable. It is very difficult to imagine the variables as a variable, or manage the variable as a thing that will be changed, that will be available, that is make to understand very changes. So what is the make changes? That is available within the changes that is used with the variable. And thirdly, there is always a danger that the variable may get altered somewhere in the program. So it is no longer a constant that you think about it. And when we talk about the hash define, that can also produce more efficient and more easily understandable program. And this directive is used extensively by the C programmers, as you will see in many programs in this book. And there are 3 examples that shows places where a hash define directory is popularly used by the C programmer. This is many a times used to define the operators as shown below. This is hash define and this is hash define or. Now next part is a macro with the argument. So we are going about the macro without the argument. Next is macros with the argument. That we have just used are the simple macros, and macros can have also argument also. So we have just talk about the macro with only the simple one. So macro have argument also, just like a functions can, and this is the example, that is how to use the macros. So we are using the macros with the argument. So we have so-called is the macros, very simple macros, and they have arguments also, just like a function have a. So this is an example that illustrated how to use the argument or how to supply the argument. That is a hash define area x 3.14 into x, then main float r1 equals to 6.25. We are declaring the variable as r1 that have a value 6.25, then r2 equals to 2.5, then a. Then we are using the a as a function or a as a variable for storing the values, that is area r1, that is printf area of a circle, then a equals to area r2. This is also a printf area of a circle a, and this is the output of the program. This is the area of the circle. This is 122.65, this is 19.625, and this is the area that is available with this, that is 3.14 into x into x into x into x, and the statement that the area r1 in the program causes the variable r2 to be substituted for the x. Therefore the statement area r1 is equivalent to, this is 3.14 into r1 into the r1. And after the above source code had passed through the preprocessor, what does the compiler go out of work on? Will this one. This is the main function. Then float r1 equals to 6.25, r2 equals to 62.25, then a equals to 3.14 into r1 into r1. So this is used with the a, that is 3.14 into r1 into r1, then area of a circle is a. Then a equals to 3.14 into r2 into r2. This is printf area of a circle is a. So this is printed with the a and a. And this is another example of the macros with the argument. This is hash define is digit y, then y is less than 57. This is char ch, printf internet digit, scanf ch. Then is digit ch, then printf you enter a digit, then illegal input. So this is printf enter a digit for the data, then scanf what is the ch that is used, then how to use the is digit ch, then printf you enter a digit. And be careful not to leave a blank between the macro templates and its argument while defining the macros. For example, there should be no blank between the area and the x in the definitions. That is hash define area 3.14 into x into x. And if we were to write area instead of the area x, then the area would become a part of the macro expansions, which we certainly don't want. That is used in the templates R1 R3.14 into R1 into R1, which won't run, not at all what we wanted. And the entire macro expansion should be enclosed within the parentheses. That means entire macro expansion, whatever we use, whatever we deal, that should be enclosed within the curly braces, within the parentheses. That is an example what would happen if we fail to enclose the macro expansion within the parentheses. So hash defines square n into n, then main function int j equals to 24 divided by square 4. Then printf j equals to percentage d gen j. This is the 64, then square of the 4, that is the 16. So 64 is divided by the 16, that is 4 is the output. And the output of the above program would be 64. Whereas we are expecting the j equals to 4. What we wrong, that indeed the 24. So this is split into the multiple part, that is used with a slash present at the end of the each line. And program shows how we can define and use a multiple line macros. That is hash define h line for I equals to 1, I is less than 79, I plus plus. Then printf for 96 for this one. And if for any reason you are unable to debug a macro, then you should view the expanded code of the program to see how the macros are being expanded, how they are using